Hello, students. I am Professor Thomre here. Today we will study chapter number 5 given in the syllabus of NCERT, that is periodic classification of elements. First, introduction. So 115 elements was discovered till today. So in the periodic table there are 115 elements. Each of these elements possess different properties, and it is difficult to understand the use and properties of each element at a time. Hence, these are man-made discover ways to learn the properties of elements in the systematic order. So different scientists try to study the properties of elements by putting in the tabular form. So the first scientist who tried this systematic classification of elements, that is Dobereiner, and the name given for this is Dobereiner's triad. So Dobereiner classified elements into group of three. So this group of three elements, it is called as a triad. The characteristic is atomic mass of second element. Atomic mass of second element of triad is nearly equal to the arithmetic mean of atomic masses of two elements. Elements in the triad have similar properties. Here one example given, that is lithium atomic mass 7, sodium atomic mass 23, and potassium atomic mass 39. So if the sum of these elements, that is 7 plus 23 plus 39 divided by 3, so that gives 23. So the sum of arithmetic mean of these masses is equal to atomic mass of middle element. So that is a Dobereiner triad. Then limitations. The Dobereiner's idea of classification of elements into triad did not receive the wide acceptance, as he could arrange only 9 elements from the triad. So this is applied only for few elements, and hence this theory is not useful to study all elements in the periodic table. Then next scientists try to classify elements, that is called as a Newland's law of octave. So Newland, an English chemist, give the law of octave. Till then 56 elements were known according to this octave theory, and the Newland's octave law states that if elements are arranged by increasing order of their atomic masses, elements are arranged according to their increasing order of masses, then property of every eighth element repeats, that is starting from the first element. So this is the first element, second, third, fourth, fifth, sixth, seventh, and the eighth one. So after eighth, so lithium is the first, fluorine is seventh, and the sodium is eighth. So lithium and sodium, these are the first and eighth element. Then beryllium and magnesium. Beryllium is the first, magnesium is eighth, boron is first, and aluminum is eighth element. So every eighth element have the similar properties, that is called as a Newland's octave. It is similar to sa re ga ma pa dha ni sa. So again sa repeats after 8. So that is called as a Newland's octave law. limitation of this law is applied only for 56 elements in the periodic table, but we know there are 150 elements and therefore it is not applied for all elements in the periodic table. So similar properties elements as per the law was seen up to the calcium only, and only 56 elements known at that time were talked about. At the time, around one element was discovered every year, and the elements to be discovered were not considered. At many places, two elements were placed in a single slot, that is cobalt and nickel. Placing of iron far away from the cobalt and nickel, which have similar properties of iron, could not be explained. So that is the limitation of this Newland's octave law. So next law for the classification of element given by Mendeleev, and Mendeleev classified these elements on the basis of their atomic masses. So Mendeleev arranged elements in increasing order of their atomic masses. He tried to put elements with similar properties in a group. Due to this, we find the empty boxes in his periodic table. So some properties are given: formation of oxide. So after this, we will study this Mendeleev periodic table. So this is group 1, 2, 3, like this. There are 8 groups. Each group is divided into subgroups A and B. So first group is divided into first A, first B. Similarly, second group is divided into second A, second B. Like this, each group is divided into A and B types. Then these are the oxides of formula of oxides of these elements, general formula for the oxides and hydrides. So this is a hydrogen. Then next is a lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. So this mass goes on increasing. Mass of hydrogen is 1.008, lithium 6.939, beryllium 9.012, like this. Mass goes on increasing. According to this, these elements are arranged. So these are the periods and these are the groups. So group 1 to 8 and the periods 1 to 6 period. This is Mendeleev periodic table. So the properties of group studied by Mendeleev. First is the formation of oxide. Oxides are the compounds of element with oxygen. For example, lithium oxide, Li2O, sodium oxide, potassium oxide, and these are the magnesium oxide, calcium oxide, zinc oxide. They are having formula RO, and these oxides have formula R2O. Then formation of hydride. Hydrides are the compounds of element with hydrogen. So horizontal row presents in the periodic table, they are called as the periods. Vertical columns, these are called as the groups. There are a total 8 groups in the Mendeleev periodic table. They are numbered from 1 to 8 and they are divided into A and B subgroups. The properties of elements in a particular period show regular gradation, means increasing order or decreasing order from left to right. Then group 1 to 7, they are subdivided into A and B subgroups. Group 8 don't have any subgroup. All elements in a particular group have similar properties. They show regular gradation in their physical properties and chemical reactivities. So these are the elements arranged in the Mendeleev periodic table. So merits of the Mendeleev periodic table, that is the advantages. So at that time 63 elements were known. So Mendeleev discovered the prediction of new elements. The Mendeleev periodic table had some blank spaces. These vacant spaces for the elements that were yet to be discovered. So before discovery of these elements, Mendeleev leave these some spaces in the periodic table. He proposed the existence of some unknown elements and given name as a Ica boron, Ica aluminum, Ica silicon. So Ica boron name as a scandium after discovery. Ica aluminum was named as a gallium after discovery, and Ica silicon is a germanium. So remember these names also. Ica boron means scandium, Ica aluminum means gallium, and Ica silicon means germanium. Now, there are some limitations of this Mendeleev periodic table. One of the limitation is position of isotopes. We know isotopes are the atoms of the same element having different atomic mass but similar chemical properties, and isotopes are placed together in the Mendeleev periodic table. They have similar properties. So this is not explained by Mendeleev. That is why isotopes have the same position, why they don't have the different position. That is not explained. Then anomalous pairs of elements. At the some location, elements were put in the order of decreasing atomic mass. For example, cobalt, nickel, and tellurium and iodine was not explained by Mendeleev. Then position of hydrogen. The properties of hydrogen are similar to group 1 as well as group 7. Mendeleev placed it is in the group 1 without any proper explanation. Therefore, this is one of the limitation in the Mendeleev's periodic classification of elements. After this, we will study next classification of these elements in the periodic table. It is given by Mosley and it is based on this concept. So first we will study this atomic number. Atomic number means it is the total number of protons present in the nucleus and it is denoted by symbol Z. Two different elements will have always different number of protons. Atoms of the same element have same number of protons and this denoted by atomic number Z. In fact, elements are defined by number of protons and possess for hydrogen Z equal to 1 because hydrogen atom has only one proton present in the nucleus. So that is about the atomic number. Now electron distribution in orbit. This is the structure of atom. So atom consists of at the center nucleus and around this nucleus electrons are revolving in different orbit. These orbits are called as a shell. So first shell is n is equal to 1, that is called as a K shell. Then second orbit where n is equal to 2, that is called as a L shell. Then third orbit where n is equal to 3, that is called as a M shell. And fourth orbit where n is equal to 4, that is called as a N shell. So this is structure of atom and the orbits around this nucleus, their numbering and denoted by K, L, M, N shell. Rules for electron distribution. First rule is an orbit can have maximum 2n square electrons. This is the formula for the calculation of number of electrons in an orbit. So first orbit, that is called as a K shell where n value is 1. So 2 into 1 square is equal to 2 electrons. This is the maximum capacity of the K shell, that is the first orbit. Second orbit, L shell, 2 into 2 square, that is equal to 8 electrons in the second orbit. Third is M shell, that is 2 into 3 raised 3 square, that is equal to 18 electrons in the third orbit. Fourth orbit, N shell, where 2 into 4 square, that is equal to 32 electrons. Like this, we can have 1 square, 2 square, 3 square, 4 square multiplied by 2. We get maximum capacity of that orbit or shell. Then second rule is orbits are filled from inside to outside. So first they filled inside, that is first orbit, then second orbit, then third orbit, like this order of filling of these electrons from inside to outside. First n is equal to 1 shell is filled, then n is equal to 2, and so on. Then third rule is the most outermost shell of an atom cannot accommodate more than 8 electrons. Even it has a capacity to accommodate more electrons. This is very important rule and also called as the octet rule. The presence of 8 electrons in the outermost shell makes atom very stable. So electronic configuration of some elements are given here. So this is hydrogen atom consists of nucleus at the center. N is equal to 1. So first orbit and 1 electron is present in the hydrogen atom. Then helium atom second. This is a nucleus. N is equal to 1. So there are 2 electrons. They are filled in the first orbit. This is the capacity, maximum capacity of first orbit. Now the next atom is lithium. Atomic number is 3. So first 2 electrons are filled in first orbit and third electron in the second orbit. Next is a beryllium, atomic number 4. So there are 4 electrons. First 2 electrons are filled in first orbit and the remaining 2 in the second orbit. Next element is boron. First orbit have maximum capacity 2 and remaining 3 electrons in the second orbit. Next element is carbon. First orbit have 2 electrons and remaining 4 electrons in the second orbit. Then valency or valence electrons. Valence electrons are the electrons in the outermost orbit of an atom. Outermost orbit is also called as a valence shell. Then stable and unstable electronic configuration. If K shell, outermost shell of an atom, and if atom has a 2 electrons, then outermost shell, or K shell is not outermost if atom has 8 electrons in the outermost shell. The arrangement of electron is called as a stable electronic configuration. Next point is the modern periodic table. So this modern periodic table was given by, that is a classification of elements given by Moseley, and this is based on atomic number. This is very important property of atom or the element, that is atomic number. So this table is called as a modern periodic table. The basic concepts of the modern periodic table are the properties of elements are depend upon number of valence electrons, and element having the same number of valence electrons are grouped together, and elements in the group have similar properties. So this is the basic concept to classify elements in the modern periodic table. Now the characteristics of modern periodic table. Before this, we will say this arrangement of elements in the periodic table. So first characteristic is in the periodic table, elements have been arranged by increasing atomic number. This is the basis for the classification of elements. Remember this well. Horizontal rows in the periodic table, they are called as a periods. There are 7 rows in the periodic table. Each row is called as a period. Periods are numbered from 1 to 7. The first period is the shortest and contains only 2 elements, hydrogen and helium. Second and third period are called short periods, contain 8 elements each. Fourth and fifth periods are long periods containing 18 elements each. Sixth period is very long period containing 32 elements. The vertical columns are called as the groups. So there are 18 groups in the periodic table. Group 1 is extreme left side position containing alkali metals, lithium, sodium, potassium, rubidium, cesium and francium. Then group 18 contains, it is to the extreme right side of the periodic table. It consists of noble gases. They are called as inert gases or rare gases, having examples helium, neon, argon, krypton, xenon and radon. So these are the examples and these are the characteristics. Now we will study actual this how periodic table arrangement in the modern periodic table for the elements. So this color indicates the alkali metals. Then alkaline earth metals are these one. Lanthanides are these elements. Then actinides are from actinium to nobelium. Then transition metals are, then this is series 1, series 2, series 3 and series 4. So there are 4 series for the transition elements. Then poor metals, these are the poor metals. Then metalloids, these are the gray colored metalloids. Then moderately active nonmetals, these are moderately active nonmetals. Then highly active nonmetals are these one. Then noble gases, they are present in 18th group. So these arrangement of elements in the periodic table that is shown with different colors. So this is a group 1, group 2, group 3, 4, 5, 6, 7 like this up to 18 groups are there. So there are total 1 to 18 groups in the periodic table. This is row 1 consists of hydrogen and helium. This is called as a period 1. Then period 2 and period 3 consist of 8 elements each, starting from lithium to neon and sodium to argon. So this is period 2 and period 3. Each consists of 8 elements. Then period 4 and 5 consist of 18 elements each, starting from potassium to krypton and rubidium to xenon. Then sixth period consists of 32 elements, not only here, but it consists of this lanthanide also. So there are total 32 elements in the sixth period and seventh period is incomplete. So this is the classification of elements given by Moseley called as a modern periodic table. Then trends in the periodic table. So first is valence electrons and the valence shell. So across the period means horizontal, these valence electrons increases from left to right. So valency 1, 2, 3, 4 like this increases from left to right and valence shell is constant. Then down the group, this valence electrons remain the same, meaning is group 1 elements have valency 1, group 2 elements have valency 2, like this group 18 elements have valency 0, group 17 elements have valency 1, that is a -1 valency. So that is the valence electron remains constant in a group and valence electron increases in the period. Then valency across the period, valency increases till group 14 and then decreases till group 18. Now down the group valency remains constant. For example, group 1 element have one valency that remains the constant. Then size of atom. size of atom across the period. As we move from towards the right, that is left to right, then positive charge on the nucleus increases, number of electrons also increases, and therefore there is an attraction between nucleus and electrons, and size goes on decreasing from left to right. Then in the group, we know in the group number of shell goes on increasing, and therefore size increases in group. Fourth property is metallic character. So metallic character across period. So across period, this metallic character decreases from left to right, and down in the group, it increases in the group. So that is about the metallic character. Then electronegativity. So ability of atom to lose electron, that is called as a electronegativity. So electropositivity is the high. It is easy to lose electron, and electropositivity is low and it is difficult to lose electron. Across the period, this electronegativity decreases, electronegativity increases from left to right, and in group electronegativity, it decreases because from non-metal to metal this character goes on increasing, and therefore this electronegativity, it decreases in the group. Then chemical reactivity across the period first decreases, and across the period this chemical reactivity decreases across the period, and in the group it increases because from metal, this from non-metal to metal, and therefore it increases in the group. Then limitations of Mendeleev's periodic table. First is the position of isotopes. This we had studied in the Mendeleev's periodic table. So next point is, so this point we had already studied, and that is about this chapter, periodic classification of elements. Thank you.